Section 8.2 is going to continue with the proportions that we kind of stressed yesterday. Yesterday we learned or talked about two properties with proportions. And we told you there was two more. That's where we're going to start. So let's just quick recap. The two that we learned yesterday were the what?
Cross product property. So we could cross multiply.
You guys know that.
And the reciprocal property.
And that's
so
just
if we took the reciprocals of each one, it was the exact same thing.
So the first one is more just to help you solve. The second one is more just to rewrite it. Now, the two that we're going to learn today are essentially just another way of explaining that if you set up a proportion one way and then your person that's sitting next to you, your neighbor, is setting it up a different way, but you still get the same outcome, that's okay. Because, so really, 3 out of the 4 are all about rewriting them. Just writing a different way. All right. Now, one thing to notice, neither one of these have names. No big deal. All right. So let's just kind of explore what's happening. So both of them are if-then, your conditional statements. So notice how they start. It says if A over B is equal to C over D. So you have a true proportion. This part we know is true. They're saying then A over C is the same thing as B over D. Okay. So what are you noticing happen here, Ms. Hochgraby?
I noticed that really the B and the C switched places.
And we could call those kind of your means position.
Yeah.
So means, these kind of switch.
Or you could say the extremes. Yeah.
B and C kind of switched.
In fact, I remember yesterday, the very last example, we kind of talked about the fact that there were a couple ways you could have written that. And it wasn't based off the reciprocal property, but it was based off of this property right here.
Exactly. So if you switch the means, in a sense, it still works out. Now, what if I switched the extremes? So if I did that, it would be D over B is equal to C over A.
Okay. Well, I'm still going to have an AD, and I'm still going to have a CB or BC when I cross multiply.
So when you cross multiply, let me make a note of that. So when you cross multiply, you're still like this one's going to get you AD is equal to your BC, and this one's still going to get you the AD is equal to BC. And this one is AD equals BC. So basically, you're still going to get the same end result.
Right.
So it doesn't matter. Now, this is where you have to be careful, though, okay? You can't necessarily switch, like, everything around. like yesterday, we talked about reciprocal. You can't just switch A and C and then not switch the B and the D, okay? Right. So just be cautious about that.
This is really just more for you guys to realize that, like Ms. Palermo said earlier, if you notice that you have a proportion written one way and your neighbor has a proportion written a different way, there are sometimes other ways to write those proportions. What you want to be careful of is to make sure that those things that correspond with each other are either going to be one right on top of the other or right next to each other in that proportion.
Exactly.
And all of the things that correspond, you should see the correspondence that exists.
Perfect. Okay, now this next one's a tad different. Notice it still starts with the same true proportion, the A over B equals C over D. Then they're saying A plus B over B is equal to C plus D over D. So what are you noticing we're doing?
It looks like I'm adding the denominator of the fraction to its numerator each time.
And they're saying this true. This is a property. Properties are true. So why would this actually work?
Well, can we cross multiply it and
Let's do that.
Okay.
Okay, so what would that look like if I cross multiply?
So I'm going to say D times the quantity of A plus B is equal to B times the quantity of C plus D.
Which means you're going to have to then what?
Multiply. So I'm going to have AD plus BD is equal to BC plus BD. Oh, okay. I see a BD on both sides. So if I use that SPO, that subtraction property of equality, I'm left with AD equals BC.
Which that's what, because these were the same, that's what you get when you cross multiply.
Wow, that's kind of interesting that if I just add the denominator of the fraction to its numerator on both of those fractions, it's congruent. They're the same, or
exactly.
equivalent.
Now, what's kind of cool, and this is another way to kind of even think about it. When you have a sum and you're dividing by just one number, it's basically you're dividing that number into each of them. So it's like saying A over B plus B over B, right? And then do the same thing over here. Kind of divide each piece by that.
Separate it.
And basically, notice this is just one. This is just one. So if you subtract the same on both sides, notice what you're left with is A over B equals C over D.
That's
another way to kind of see it. But what I like here, I want you to notice here, on both of these properties, the way we ended up kind of proving them, because essentially we kind of showed why it worked, is we use the cross multiplication property.
Right.
So the reason why I bring that up, because on some of these examples, they're going to ask you to decide if the statement's true or false. And if it's a true statement, we're going to use that cross multiplication property to prove if it's true.
Okay.
Okay? If it's false, what do we usually do when something's false? What do we usually have to do?
Either show that it does not work.
So how do I show that?
Kind of show a counterexample?
A counterexample.
Okay.
Exactly. So kind of keep that in mind, because if you'll look at the next slide, all right, that's exactly what they're saying. They're saying decide basically if it's true or not.
Okay. So first of all, as you take a look at this, they give us a conditional statement. We've got an if and a then. And we're deciding if the statement is true. We have to assume that we're given something that is true. So you know that this part is true, the if part.
Okay.
Okay, this is true. This is...
You always have to be given something to start with true. The
Right.
if is always given. Kind of in a proof, it's always the true part. Okay.
The question is, then, knowing this is true, will x over y equal 3 over 2? Okay, so we talked about this a little bit already. Mrs. Palermo, what would I do to get started? What do you think would be a good approach?
Well, let's cross multiply.
Let's cross multiply.
Sorry,
Okay, so,
I ate a little piece of popcorn. I wasn't ready for her to ask me a question.
sorry. When we cross multiply, what do you get when you take x times y?
So xy equals, so 150.
150, great. And I'm just going to stop right there.
Okay.
Okay. Now, let's take a look at what we're trying to see if that is also true. Because if this is also true, I should end up somehow with like an xy equals 150.
Okay.
Okay, so as you cross multiply this one, I end up with
2x
is equal to...
3y.
Now, just by looking at these, do they look the same?
They don't look the same. So they obviously, we haven't proven it's true because it didn't show that it's true.
Right. So then how could I show that it's false?
So I'm thinking if it's false, we're thinking it's false here, then we would have a counterexample. Now, keep in mind, guys, there are values that actually make this true. There is a way to make this true, but we want a counterexample. Remember, for it to be true, it has to work always. So this shows, what Ms. Huckgraby wrote down, shows that it doesn't work always. Okay?
Because if it worked always, this would say xy equals 150. This would say xy equals 150.
Okay, there is a way to find values for x and y for this to make work, but we want a counterexample, and we only need one. So let's think of some numbers for x and y.
Okay.
And I know, based on what you said, that x and y, whatever they have to be, they have to make that first part, the if part, true.
Right.
Okay, so I know that whatever x and y have to be has to make that true,
So
but I also know they have to multiply to get 150 as well. Okay, so I'm thinking, let's say x is, let's say 30. All right, so then y would have to be 5.
Okay.
Okay, so I know that if I do the 30 times 5, that gets you the 150. That does work. Okay.
Right.
And you can also see that in the original proportion. If I put 30 in for x, 30 over 10 is 3, and 5 over 5, or 15 over 5 is 3 as well.
Right.
So another way you can look at it. Okay, so I got to put it in there, and if I do the 2 times the x, which is 30, and I'm going to see, does it equal the 3 times the 5? Okay, so that's, what, 60? And that's 15, obviously not the same. So that showed why it didn't work. So your counterexample would be when x equals 30 and y equals 5. Now, do I need to show that why it doesn't work, like off to the side? Should I show
that work?
Mm-hmm.
Yes, definitely.
Yes.
Definitely.
So you don't want to just pick any numbers and say, okay, it's a counterexample. Show why it doesn't work.
This work is important to show that it does work here, but that it does not work here. That's why I've said does not equal. Now, keep in mind that that's not the only counterexample you could have listed.
There lots of them.
An infinite number of counterexamples we probably could have chosen here.
But whatever you pick, it has to work for the first if part, right?
But not the second part. Exactly.
Okay, same basically directions, just a little bit different
Example.
if and statement. Okay, so again, just to stress, this part right here is the true part. You're starting with true. The question mark is this. Is this true or false? All right?
Okay.
So what are we going to start by doing first?
So we want to start by cross-multiplying the first proportion.
All right,
So we want to say, that'll be 3y equals 5x.
And again, this is the stuff, this is the kind of work that you're going to show. Because if it ends up being true, we can stop because we've actually shown it. If
Right.
it's false, you need to again give us a counterexample.
Okay.
All right? All right, over here, what would I write?
All right, so there when I cross multiply, I'm going to have y times the quantity 3 minus x equals x times the quantity 5 minus y.
Perfect. This kind of looks similar to something we did before.
Yeah, it does. Okay. When I distribute, I'm going to get a 3y minus xy is equal to a 5x minus xy. And I notice on this one there's a negative xy on both sides. So I could go ahead and, if I added that to both sides, use a little apo, I end up with 3y equals 5x. And they're exactly the same.
These are the same. So what did I do here?
I've proved that this is true. As long as those equations are identical, it's true.
So this last one, I don't know, did we ever write false?
Oh, I don't
No.
think we actually did.
We said it, we just didn't write it. So this
Yeah.
is a false statement. I was just thinking, I was like, so this is a true statement because of the fact that when you cross multiply in the end, it ended up being the same.
And this looks exactly like that fourth property. What I notice is different. Instead of adding the denominator both sides, it looks like we subtracted the denominator from both sides. But it's like adding an opposite. I mean,
Yeah.
it's the same idea.
Well, and it's kind of like that first property we learned. We talked about that there were different ways that you could write this one. So this one is not limited just adding to the denominator. You could actually add the numerator to the denominator as well. So you could basically, these could be flip-flopped.
Right.
So using the reciprocal property. So those properties are, I mean, it's just one way of seeing it. If you're not sure, okay, you can always just, check it by cross multiplying, see if it ends up being the same.
And we're going to want to see that work anyway, so it's okay. All right, next one. In this one, it says we're going to find PQ, which is the measure of this segment. So this is what I'm finding right here.
Okay.
Okay. And they give us a proportion. We know that some things in this figure are already proportional to each other. And if you look at this, we even have some numbers that we could maybe substitute into some of these parts.
I think that's an excellent idea.
All right. So as you take a look at this first proportion, what do we know about MQ, the measure of MQ?
Well, it's made up of MN and NQ, so I add those up, that's 21.
Right. So I'm going to say, okay, 21 over, and what do you know about MN?
6.
And it's equal to, and they say LQ.
Okay, we don't know LQ.
No.
Okay, so, and we're not asked to find LQ, but I can think of a couple different ways to do this. So I noticed because they're asking to find PQ, LQ is made up of PQ and that LP. So if I add the LP and PQ together, that gets you the LQ, right? So I
Right.
could say LQ is maybe 5 plus the PQ.
I love that. And I like just leaving it as PQ. So we know exactly what we're talking about. I'll have students that say, can I just call this part X? Well, you can, but if you do that, please label it in your picture so you know what you've labeled as X. Because are we talking about all of LQ as X? Or are we talking about just this segment? We need to be able to know what we're referring to. I love the idea of just leaving it as PQ.
Perfect.
Okay.
Why don't you label the picture kind of like you did on MQ as 21. Let's label it 5 plus PQ. That way everybody remembers where we're getting
Absolutely.
at. Over
Okay. And LP, which we know is
is 5.
right.
Well, this just is solving a proportion.
It is just
That
solving a proportion.
seems so easy. Okay.
Exactly.
And that's something, guys, this whole chapter, you're going to be solving lots of proportions. So it's
Right.
really important you know how to solve it. But it's the setting up part that really what you need to focus on.
Right.
Okay? All right, so you're going to go ahead and cross multiply. So I get, what, 105. 21
That's very
times 5 is 105.
Uh-huh.
Equals, can I just, do you want to, okay, right? 6.
Well, I'm going to write it, but
Okay.
I'm not, yeah, we can talk about that too.
So 6 times the quantity of 5 plus PQ.
This is something, if you guys can move past this step of your paper
Go ahead and
go
distribute in a
straight
sense.
to the distribution, we're fine with that.
Okay.
I just want you guys to see where I'm getting this from.
So that's going to be 30 plus PQ,
6 PQ.
or 6 PQ. Sorry.
And then,
Subtract 30 on each side, so it's going to be 75 is equal to 6 PQ. And then when I divide, I get PQ is equal to 12 and a half. So 12.5.
now, is that what they asked us to find?
It did. So we're done.
So we're done. All right, guys, keep in mind, these are all equations. You can check yourself. After you've got that, say, okay, if this is 12 and a half and I add 5 to it, the whole thing would be 17 and a half. Does that proportion work when I try those numbers? You can always check them. But yeah, once you've got the setup part down, then it's a matter of just solving. Great.
All right, so this next example, it just says solve, right? It's a proportion. So how do we solve a proportion?
We're going to cross multiply.
All right, so what are we going to multiply first?
I'm going to say, let's do the x times x.
Okay.
And I know x times x gives me x squared.
All right. Oh.
And when we take 36 times 128, we end up with 4,608.
All right. And again, just a reminder what she did. She did x times x, and then she did the 36 times 128. And you actually had a question similar to this on our algebra review.
Uh-huh.
If you remember what we have to do now.
We need to square root both sides to get rid of a square, which is going to give us x is equal to, and technically it's plus or minus. We're not talking about a side length here, so we can have negatives.
So plus or minus.
And it's not very beautiful, but we're going to go ahead and call that 67.88.
And it's an approximate because we had to round because it's not a perfect square.
Right.
Okay, well, here's the deal. This is just a kind of refresher of Algebra 1, just cross multiplying. And then this ends up being a quadratic because of the fact that you have an exponent of 2. And when you get that, you're going to end up a positive and a negative. Now, this is going to lead into something that we're going to be using, not just this chapter, but chapter 9, which is coming up. This is just to introduce it. Now, I want you to notice before we get to that, notice that the thing that we're finding, the unknown, it's located in 2 spots of your proportion. And what do you notice about that?
These are the means.
These are the means. When
Or you
they're
could
kind
say
of
they're the
diagonal,
extremes either way.
right? These are the means. This is the mean spot, all right? This is something unique, all right? And I'm going to go ahead and go to the next slide and have Ms. Hograby keep going with it. This is what we call
the geometric mean. And you guys, when we hear the word mean, a lot of times you guys think of the arithmetic mean. When you're using basic arithmetic, you're averaging.
the average. And average would just be adding and then dividing by
However many you have. Exactly. And so a lot of times when we hear geometric mean, people say, oh, we're just finding the mean in geometry. And it's not the same thing. There is a very special thing called the geometric mean, and it is exactly what we just did, really, in a sense. It is when we have 2 positive numbers, and they are going to have to be positive numbers, and I'll tell you the fact that it's a geometric mean, we're using this within geometry, so a lot of times you're talking about side lengths and things. So you're going to be looking at the positive values. So 2 positive numbers, A and B, such that, and the positive number x, such that we can write this proportion. That we would say A over X equals X over B. Notice this looks just like that last example that we had, where the X's are our means. One thing we said that we really took like an X squared was equal to that AB, right? When we cross multiplied. But I want you guys to realize that when we took our square root, that X value was equal to the square root of the product A and B.
Okay.
This right here is the formula for geometric mean.
Or you could set up the proportion.
But yes, you can most certainly use the proportion.
It just depends on what you're comfortable with. Something I want to comment on, she mentioned it. Notice that the value of X, it says it's the positive number X. So the last one, when we just solved that proportion, it didn't say anything about, we said plus or minus. So in this case, the X is just going to be positive because of the fact that you said it's dealing with the geometry, which is normally side lengths. Yes. So the good thing is you don't have to worry about that plus or minus.
Right.
Okay.
So if I said give me the geometric mean of 2 numbers, then we could put those 2 numbers in for our A and B to find what that geometric mean will be.
Okay.
Okay. Easy enough formula.
All right. So let's try a couple of examples.
Okay.
It says on both of these, it says find the geometric mean of, and notice how they give you the 2 numbers you're finding the geometric mean of. Okay.
Right.
So when you see that, when it says find the geometric mean, you can kind of set this up a couple different ways. You can set up as a proportion, right? And kind of what I do is a lot of times I know, okay, it's a proportion, set up, I know that I'm going to have 2 fractions that are equal. And since it says find the geometric mean, that's going to be our unknown. So I'm going to put that in kind of the mean spot. And then what am I going to put in the other spot?
The 8 and the 18.
The 8 and the 18. So then it's just a matter of solving, no big deal. Another way you could set it up, okay, is by
the geometric mean formula.
Okay.
So X would equal the square root of 8 times 18. Sorry. Were you going to write A and B?
Uh-huh.
Sorry. I just went
no.
straight to putting the
I
numbers
was
in
writing
there.
the formula out and you just went straight there. That's
okay.
fine. And essentially, guys, this means the same thing. This equation comes from this equation.
Right.
So they're exactly the same thing. It's just how you want to interpret it. Either way, when you set it up, we want to see kind of how you set it up and then go ahead and answer it. Okay?
Right.
So
don't just give us the answer.
don't just multiply and tell me what this is. Show me what you're doing here with it. So this one, if you do it this way, it'd be x squared equals, what is 8 times 18? What is that?
144.
And then x ends up being
12.
12.
Again, technically it'd be plus or minus 12, but because we're doing geometric mean, it's just the positive.
Exactly. And then this, if you should work, it'd be the square root of 144.
Which is still 12.
Still 12. Notice one thing to keep in mind, and I like that she brought this up about the mean that you're used to, kind of the average. The average is kind of exactly, it is
the exact middle.
Yeah.
Of those values.
Well, notice 12, if I found the actual average, if I add 8 and 18, what is that? That's 36. And I cut that in half, that's 13. Notice that average is pretty close to that geometric mean, which is pretty common, right? It is going to be somewhere between these two numbers. The geometric mean is going to be between 8 and 18. It's just not the exact average.
Right.
Okay. All right. So tell me on this one. Set it up however you want to set it up.
I'm going to go to the formula because I like that geometric mean formula instead of doing the proportion. So I'm going to say that x is equal to the square root of 35 times 175.
All right. So if I multiply that, 35 times 175, that's
6,125.
All right.
Not very pretty. And it's not a perfect square either. So when I go ahead and take the square root, it's approximately 78.26.
And it's okay for you to round. Next chapter, when we get to chapter 9, we're gonna really stress this idea of how do I deal with these radicals
and how do you simplify them.
without.
And that 78.26 is between those two numbers.
Perfect.
All right. Okay, now this question says that the geometric mean of 12 and another number, so our other number is what's unknown, is 30. So what piece do we actually know here? We know
they give you the geometric mean this time.
Right, so this right here is the geometric mean. We don't know, and what do you want to call our other number?
Let's call it A.
Okay, so we've got our two numbers that we're finding the geometric mean of, and we actually know the geometric mean is 30.
Okay.
So the question is, what will the other number be?
Okay.
Well, we have equations we can use to help us define this, right?
Okay.
So what do you want to do?
Let's just show it both ways. Let's do
Okay.
the proportion idea, just so, because every year, and you probably see this, I have students that will like the proportion, I have students that like the other with the
Yes,
formula.
definitely.
So if they give you the geometric mean, I know that goes in the mean spot, so I'm going to put a 30 on the bottom there, and then on the top right there.
Right.
And then the one number we know is 12, and then the other we don't know, A. So those can be kind of flip-flopped. It could be
Right.
A on the top left, 12 on the bottom. The other way you could set it up is, well, the geometric mean is kind of technically the x in your formula, so you're going to have 30 equals the square root of 12 times A.
Right.
Okay.
Either one of those are going to work great. Now, over here when I cross multiply, we'll go ahead and show both
So
ways.
12A is equal to 900.
And when I divide by 12,
You get A to be 75.
okay. And what about if I do it over here? If I go ahead and
Well,
solve this
I
equation?
noticed the unknown we have is underneath that radical. To get rid of that square root, I just square both sides. So I get 900 equals 12A, which is exactly
the
what's over
same
there.
as what I've
so
got here.
either way, in the end, your answer you're looking for is 75.
Right.
Now, checking this, okay, we know that 30 is a geometric mean, and we said that should be somewhere between the two numbers, and it is between 12 and 75.
Right. Exactly.
So that's a kind of a
basic check. It's not
What's another way you could check it?
You could actually put that 75 into the formula, and either the proportion or the formula, and solve and just make sure that it works.
Good.
All right.
All right, I think this is our last example.
Yes.
Yes, it is. All right, so it says you are building a scale model of your uncle's fishing boat. All right, the boat is 64 feet long.
62 feet
Or
long.
62 feet long. Gosh, I swear I can read. And 23 feet wide. The model will be 14 inches long. How wide should it be?
Okay.
So when they say how wide it should be, what are we talking about?
They're talking about the boat. No, they're talking about the model. Sorry.
Because they give you the dimensions of the boat.
Yes, they give us all the dimensions of the boat. He's working on the scale model.
Okay, so if you think about it, what do we know about the boat? We know the actual boat, right, is, let me make a little note. The boat has 62 feet long and 23 feet wide. And the actual model, or the thing that's a little smaller, we have 14 inches long, or inches long, and, inches long, and then the unknown is how wide it is.
Okay. Well, I love that you kind of set up the information off to the side, because we could really just write a proportion pretty much right from there.
I think that's a great idea.
Because I could do length over width equals length over width.
Okay.
As long as I'm keeping those lengths in the same part of my proportion, that's one way I could write it. So I could write 62 over 23 is equal to 14 over x.
And so the x is going to be your unknown, your width.
Right.
So she did length to width of the boat, length to width of the model.
Now that's just one way I could have written it.
What else could you have done?
I could have done length over length equals width over width, so I could have done 62 over 14, but just make sure that if I do it this way, that I'm keeping those pieces that are corresponding with each other across from each other. So I've got my length of the boat over length of the model, so then I've got my width of the boat over width of the model.
And notice if you look at the two that we have written, notice basically what you did.
Oh, that's that third property where I just flip-flopped the means.
Exactly. So that's what we were talking about. It doesn't matter. I mean, obviously it does matter in the end. You want to set it correctly, but there's so many variations to this. You could do the reciprocal of these things, all different options.
Yes.
Okay. Either way, we're going to solve it. Okay. So we get cross multiply. We're going to do
So 62x would equal 322, and so x would be approximately 5.19 inches.
And we're talking about the width of the model, so that's why you said inches, right?
Right. And as I look at that, I notice that I don't usually talk about 0.19 inches, so I could also try to convert that if we want to. Just as a reminder of how to do that, if you actually divide that, you get a big long decimal. It keeps going. And if I take away the 5 part of that, because I know 5 is representing the whole value.
So you're just left with this long
This
decimal.
0.1935483, etc. And I take that times its conversion factor, so there's 12 inches in 1 foot, then I know that I would end up with about 2 inches.
Well, here's the deal.
Oh,
though.
that
This
is
already
inches.
in inches.
I was thinking feet,
Feet,
inches.
yes.
Mrs. Palermo, just stop me earlier when I start doing silly stuff.
But you could write this as a fraction, because a lot of times inches.
If it represented, yeah.
We'll probably, and I was going to stop
accept
you,
that. No, stop me. Oh my goodness. I wish everybody else is saying, man, this could have stopped a minute ago.
That's okay. This answer, we'll accept it.
Yes, because it's inches.
The other thing to keep in mind, a lot of times you'll hear us say, if you have units, a rounded answer is perfectly acceptable.
Yeah.
Okay? You'll hear us say that a lot more. So, and how could we check it? Well, we could put it back in. Notice here that the width is shorter than the length, which is very typical.
Yeah.
The other thing is,
Should
notice
happen.
this width is shorter than this width. Well, because the model is smaller. So you can just kind of eyeball it and see, okay, is this even a realistic answer? If I got a width of 20, okay, well, that wouldn't make any sense because it's longer than the length, which would never happen.
Right.
Okay?